Alright, 1.6 equations and inequalities involving absolute values. So we know what an absolute value is that whenever we had something in between these two bars, we know that it's going to come out positive. So like the absolute value of 10 is 10. The absolute value of negative 10 is still 10. And that's all this is saying, is that whatever absolute value you put into it, you're always going to get a positive value. So negative becomes positive, positive stays positive. So what that means when we're trying to solve equations, that we're going to have a positive version of A and a negative version of A. And if you're asking what the heck is A, the inside of the bars are A. Just like the example we did in class the other day where we had the negative exponent and the inside of the parentheses was A, so we had to set that greater than 0. So same thing here, inside the bars, the absolute value, that's going to be A. So what we want to do is we want to separate this into a positive equal and a negative equal. So we'll have 5x equals 15, and then we also have 5x equals negative 15, because we can plug in negative and positive values into it. So we're going to do what we always do to solve for x, divide by 5. And when we do, we're left with x equals 3. And then we're going to go move on to our second one, same exact thing, divide by 5. And then we get x equals negative 3. So, just in your head, plug it back in, make sure it makes sense. So if I plug x back in, 5 times 3, that's 15. The absolute value of 15 is indeed 15, so that works. And then if I plug negative 3 back in, so 5 times negative 3 is negative 15, and the absolute value of negative 15 is positive 15. So that's great, but there's going to be one issue with just be careful with how you mark your answers, because you see how we have two x values? So in math, because we're fancy now, anytime we have multiple values that represent a variable, we have to put it in set notation, because it allows the reader to know that we have two answers. Now, if you accidentally just box this for the first test, I'll let it slide. But after the first test, I'm going to be a lot more critical on our notation. So technically, the red boxed answer is the 100% correct answer. But on the test, if you give me the white boxed answer, I'll let it slide for the first test. So whenever we have absolute value, we're going to make a positive equal and a negative equal. Let's move on to part B. So you probably noticed something about part B. If you don't, I will underline it so we can see it. Right there, that negative 3. You notice on part A, the absolute value was by itself. So that's something we need to be careful of. I'm going to put a little star right here and say isolate the absolute value. Meaning get it by itself. So in order to get it by itself, I'm going to add 3 to both sides. And when we do, we have 3, the absolute value of 3 minus 8t equals 11 plus 3, which is 14. Now that the absolute value is completely by itself, we're going to go ahead and split this into two equations. So one of the equations is exactly the way it looks without the bars. So 3 minus 8t equals 14. And then the second one is the a is going to be the same, so inside the bars will be the same, but it's going to equal the negative value or the opposite value. So we'll have 3 minus 8t equals negative 14. And from there, we're just going to solve for our variable, which in this case is t. So we're going to subtract 3 to both sides. And when we do, we're left with negative 8t equals 14 minus 3, which is 11. We're going to divide by negative 8. And we are left with t equals negative 11 over 8. It does not matter where the negative goes. Top, bottom, middle, it just means the fraction is negative. Alright, let's solve our green one. We're going to do the same exact thing. We're going to subtract 3. And when we do, we're left with negative 8t equals negative 14 minus 3, which is negative 17. And then we're going to divide by negative 8. So we now have t equals positive 17 over 8. And we're going to write them in set notation. So when we write it in set notation, smallest number, then biggest number. So I'm going to write it up here. We have a negative 11 over 8, and then 17 over 8. Of course, simplify your fractions if you can. If questions arise and you can't really figure it out by pausing and starting again and rewinding, just put a little star in your notes being like, okay, at this part in part B, I'm not sure what happened, and whenever we get to see each other again, bring it up before or after class, and then I can help you with it, okay? Alright, part C. So do you notice anything difference between A, B, and C? And it's okay if you can't spot the difference, but there is. Look at A and B. Look at where the variables are. The variables inside A and B, they're inside the absolute value symbol. If you look at C, the absolute value is just around a number. We know the absolute value of a number, but do we know the absolute value of a letter? We don't, because we don't know what the variable or the letter means. But we know the absolute value of 2. It's 2. So let's just simplify. We'll have 2x equals negative 16. Okay, we can solve this. Let's divide by 2. And when we do, we have x equals negative 8. Now think about it. When you plug that back in, we'll have absolute value of 2 times negative 8 equals negative 16. It works. And if you can't plug it back in your head, write it out and plug it back in. That's okay if you have to write it out. And I know we only have one answer here. You still have to write it in set notation because it's a set. The values of x's, it's not x equals this. We have a set of an x value or values. Again, if you accidentally forget that for the test and you just box the x for the first test, I'll let it slide, okay? Alrighty, part D. So part D, let's look at it. Let's see where is the variable. Alright, so when we pay attention and look at it, we see the variable is inside the bars. So since it's inside the bars, we're going to need to do some splitting up. But before we do some splitting up, let's pay attention. Is the absolute value by itself? It's not by itself. It has that 1/4 in front of it. So since it has that 1/4 in front of it, we want to go ahead and get rid of it. And the way we're going to get rid of it is to multiply everything by 4. So we'll have 4 over 1 times 1/4. And that's absolute value of u minus 7. And that equals 4 over 1 times negative 1/2. So we can go ahead and cancel out these 4's, which was our goal. We're just moving it to the other side. So we have absolute value of u minus 7 equals 4 times 1/2. So half of 4 is 2 times negative. That's negative 2. Because half of 4 is 2. And now we can go ahead and split it up. So we're still going to split it up into 2, even though it's negative. But hold up, it's negative. Can absolute values equal a negative? Think about it. They always come out the positive answers, right? So let me write something. So absolute values cannot equal negative 2 or a negative value. So if you plug any number into u, it will always come out as positive. So try it. Try it. Just pick any number for u. So any number you want, plug it in as u, and simplify. So I'm going to pick 1. So if I plug in 1 as u, I have 1 minus 7, which is negative 6. But what's the absolute value of negative 6? Positive. It's not going to equal a negative number. So since it cannot be, it's impossible. When something's impossible in math, or impossible for what we know as right now, we say no solution. And that's our answer. Alright, let's move on. Part E. So part E, we have absolute values on both sides now. We still treat it the same exact way. When we have, don't we have two of them? The first one is identical, right? Just without the bars. So the first one is identical, just without the bars. And then the second one, didn't we make the right side the opposite version? So let's make the right side an opposite version. And in math, when we say opposite version or opposite, that means negative version. So we're going to slap a minus around the right side. Alright, let's go ahead and solve each side. So for the white one, we're going to subtract 4x squared to both sides. And thankfully, they cancel each other out. So we're left with 12x equals negative 5x. You might see that this equals 0, and it does. But let's add 5x to both sides. So we have on the left side 17x equals 0, because if everything cancels out when you're adding and subtracting, you're left with 0. We divide by 17, and we get x equals 0. That makes sense though, plug it in. Because if you plug in x as 0, everything becomes 0 because it has an x. Now let's do our right side, the green one. First things first, we need to go ahead and distribute this negative value. So we have 4x squared plus 12x equals negative 4x squared plus 5x. And you see how we have something in here that's squared? And that's the highest exponent. Anytime we have something that equals to squared, we want to get the whole problem to equal to 0. So what I mean by that, I'm going to add 4x squared to both sides. So we're left with 8x squared plus 12x equals 5x. And then I'm going to subtract 5x to both sides. And we have 8x squared plus 7x equals 0. So that's what I mean by equal it to 0. Move everything over to either the left or the right side. And from here we need to factor. So since this is a binomial, two terms, your only factoring is greatest common factor, GCF. So let's see if they have anything in common. And they do. They have x in common. So let's take it out. We're left with, if we take out an x, from 8x squared, we're left with 8x. And if we take an x out of 7x, we're left with 7. Mentally distribute it back to make sure you factored it out right. Now we're going to set each of them equal to 0. So we have x equals 0 and 8x plus 7 equals 0. So we subtract 7x from both, or excuse me, subtract 7 from both sides. We're left with 8x equals negative 7. Divide by 8. And we get x equals negative 7 over 8. So our two solutions are negative 7 over 8 and 0. We do have two zeros, we do, but we're not going to write them twice because that's redundant. You're not going to write 0, 0. It's already accounted for, so we only write it once. And that is our solution. Alright, now let's do this with inequalities. So remember, inequalities, Inequalities mean intervals. So if you see inequalities or the inequality symbol, you're going to answer an interval notation. You could use set notation, but we use interval notation. That's what's used in calculus. The same rules apply, actually. We treat these no different. Everything else is going to be the same. So when it's an equation, the first thing we need to make sure is to isolate the absolute value, which we are. So we add 9 to both sides, and we're left with absolute value of 1 minus 4x is less than negative 7 plus 9, which is 3. So first one, identical equation. So identical equation, we have 1 minus 4x is less than 3. And then the second one, we change the sign to the right, right? Can we change an inequality sign? We can. We can flip it, so we must. And that's what it says up here, is that when we have an absolute value that is less than, it's going to go together. And when we have an absolute value of greater than, it's going to go separate. So we have 1 minus 4x is greater than negative 3. So we flip everything to the right. Let's solve our left side. We're going to subtract 1 to both sides. So we're left with negative 4x is less than 2. Let's divide by negative 4. Don't forget we divided by a negative, so now we have x is greater than negative 1/2. Let's solve the right side by subtracting 1. And then we're going to divide by negative 4. So we get x is less than 1. Since this equation is less than always goes together. So it'll be parentheses, comma, parentheses, or bracket. It just depends on your symbol. So since this is a less than, we're going to mush them together. It'll be parentheses negative 1/2, 1 parentheses. And if we were to graph this, because it is less than, they always go together. So we have negative 1/2, positive 1, and parentheses make them go together because it's less than. That less than symbol always means they go together. Alright, part B. The first thing we need to do is isolate our absolute value by adding 2. And now we're going to separate them into 2. So the first one is identical, just no absolute value. And the second one is almost the same, except we change the signs to the right. So let's solve for these. Oh, my bad, wrong color. Alright, so first we're going to subtract 9 to both sides. So we are left with negative 2x is greater than 13 minus 9, which is 4. Divide by negative 2. So we get x is now less than negative 2. Alright, let's go on to our green one. So for our green one, same thing. We're going to subtract 9 to both sides. So we're left with negative 2x is less than negative 13 minus 9, which is negative 22. We're going to divide everything by negative 2. And we are left with x is now greater than positive 11. So do you notice this symbol here? It's a greater than symbol. Greater than symbol means they go apart. They go apart, 4 and 5. So since it's greater than, they go apart. You can also see that when we graph it. So if we look at the pink one, -2, it says x is less than -2. And you see how the arrow is pointing to the left? So we'll have our parentheses and pointing to the left. And then for our green one, it says x is greater than 11. And the arrow is pointing to the right. So parentheses point to the right. So they go apart because it's greater than. So how do we write this in interval notation? We read left to right. No matter what it is, if it's math, it's left to right. So left to right, the left side right here, that's negative infinity. So negative infinity, and then it stops at -2. Union, the union is the gap we have right here. That gap, we're going to call it union because it means and. We're going to combine the other side. And then we have parentheses 11. And since it's going to the right side of the number line is positive infinity. And it's always like that. If they go apart, it's negative infinity number, union number, infinity. Always, always, always. And I'll write that here for you. It's always going to be negative infinity number, union number, infinity. If it's greater than, if they go apart when you graph it. Alrighty, part C. So this is a less than. So since we see it's less than, if this works out, they go together. So first things first, let's simplify. We simplify because we know the absolute value of 8, or excuse me, -8, it's 8. Now we isolate. So we take that out and we're left with the absolute value of -5x is less than or equal to 4. It's a negative, my bad. It's a -4. Absolute values. Let's think about that. That happens sometimes. So no matter what x, the outcome is positive. So let's do this example together, not in our heads this time. So if I said x is 2, whatever it is, if I say it's 2, let's see if it works. So we'll have, we plug it in as x as 2. So we have -5 times 2 is -10. The absolute value of -8 is +8. It is less than or equal to 4. The absolute value of -10 is +10. And is 18 less than or equal to 4? It's not. And no matter what number you plug in, any x you can think of, from -infinity to +infinity, it doesn't work. It's not true. So to say that something doesn't work or not true, we say no solution. Alrighty, part D. It's a greater than. So let's just try and keep remembering if it's greater than, they're going to go apart. But do you absolutely need to remember that? No, because you could graph it and then see if they go apart or together. It's just a little trick to kind of remember. It might make your life a little bit easier. So let's go ahead and simplify this. We can simplify because we have something in the absolute value that we can get rid of. So we have -3x, absolute value of that is greater than 11. So let's split this up. We will have -3x is greater than 11, and -3x is less than -11. So let's divide by negative 3. We're left with x is less than a negative 11 over 3. Divide by negative 3. And we get x is now greater than 11 over 3. So if we graph this, our pink one, it's pointing to the left. Our green one, which is the bigger number, is pointing to the right. So they're going apart. So it's always going to be negative infinity number union number infinity. All right. So we have a greater than with a negative number. So 4 times the absolute value of 7x is greater than or equal to negative 4. Go back to the one that was no solution. Part C. That was less than a number. So let's see if we can be greater than a negative number. Let's simplify this first, though, because we know we're not supposed to have that there. We need to get rid of it. So we have absolute value of 7x is greater than or equal to negative 1. Think about that. No matter what you plug in, you have to multiply it times 7. Any negative or positive number or fraction, it's going to be greater than negative 1. So if doesn't matter if it's always going to work, it's negative infinity, positive infinity. Now, if you don't believe me, let's try it. So let's say x is 3. So let's plug it in. We have 4 times the absolute value of 7x, which is 3. Close out that absolute value is greater than or equal to negative 4. So we have 4 times the absolute value of 21 is greater than or equal to negative 4. So 4 times 21 is greater than or equal to negative 4, and it is. 4 times 21 is greater than negative 4. So that's why our solution is negative infinity, positive infinity, because no matter what x you plug in, it's always, always, always going to work.